Hello students, welcome to my new video. In this video, we will continue solving exercise 7.2 from your chapter 2 integration, which is based on method of substitution. In this video, we will solve question numbers 8 through 13. And in the previous video, we already did question number 1 to 7, of which the link you can see on the top right now. Even if you haven't checked that video out, you will be able to understand every single sum that I teach you here crystal clear. That's my guarantee. Let's see what we are covering. So if you have square root of x, and if you want to put it as t, you should have square root of x in the denominator. Whenever you see the composite function in integral, most likely it is method of substitution if the derivative of that composite function is present. In this case, if this is my
here
u,
we need x
what is the
square
derivative
times
dx? We need x square dx. If you want x square dx from here, therefore we get x square dx. Take dx in the numerator and 9 in the denominator is equal to dt by 9. Okay. All right. Let us start with question number 8. It says integration of x multiplied by square root of 1 plus 2x square. If you notice clearly that 1 plus 2x, square root of 1 plus 2x square is a composite function. Okay. What do I mean by composite function? If I had square root of x, this was a simple function. But if it is square root of u, this is composite function. In this case, my u is this 1 plus 2x square. Okay. Now that 1 plus 2x square, is the derivative of 1 plus 2x square present in this integral? If you notice the derivative of 1 plus 2x square, the derivative of 1 is 0. For derivative of 2x square, it is 4x. Okay. 4 is not present, but that x is present here. So we can manage the 4 because it's a constant. It can be easily managed. Okay. Now, because it's a composite function and the derivative is somehow present, the x is present, 4 is not present, which can be managed. We can say that we can use the method of substitution, and we can say put 1 plus 2x square is equal to t. 1 plus 2x square is equal to t. Okay. Then you differentiate with respect to x. So you get, therefore, derivative of 1 with respect to x is 0. Derivative of 2x square with respect to x is 4x. Derivative of t with respect to x is dt by dx. Okay. Now 0 plus 4x is 4x times dx is dt. But if you notice here, I really need x multiplied by dx. Okay. What I really need is x multiplied by dx. So if I want x multiplied by dx, here x times dx, I can take that 4 in the denominator, dt by 4. Which is why I said initially that constant can be managed. Only the variable part is important. That should be present when you may do method of substitution. Okay. Now let's say this is integral. Let's convert this entire integral in terms of t. Okay. So x dx is dt by 4. Sorry. So yeah, x dx is dt by 4. And this is square root of t. Okay. Square root of t. That's my integral. Okay, now this is very simple. This 4 is constant, can be taken out. So it will become 1 by 4 integration of root t dt. Okay. Okay, remember that t is nothing, root t is nothing but t to the power 1 by 2. So that will become 1 by 4 integral of t to the power half dt. Okay. Now, in order to now integrate this, it's very simple. 1 by 4 t to the power half, the integral, it's just like x to the power n. It is t to the power half plus 1 divided by half plus 1 plus add the constant of integration c. Don't add the arbitrary constant when you're done integrating. Okay. Now that t to the power, the t can be replaced again. T was 1 plus 2x square. If you remember correctly, t was 1 plus 2x square. So we can do that replacement again. So we can say 1 by 4 t to the power 3 by 2 divided by, oops, sorry. We need to substitute instead of t 1 plus 2x square to the power 3 by 2 over 3 by 2 plus c. Okay, because t is 1 plus 2x square. Now this 2, is in the denominator's denominator. Denominator's denominator always goes in numerator. So this 2 can go in the numerator. So that will be 2 by 4. 1 plus 2x square to the power 3 by 2. Don't forget that divide by 3 plus c. Now this will become 2. 3 times 2 is 6. So that will be 1 plus 2x square to the power 3 by 2 divided by 6 plus c, and that's your final result for this question. Okay, I hope that makes sense. Let's proceed in solving question number 9. We have this integral here. If you notice, this is again the composite function, right? Square root of u. Let's see if that derivative of u, which is this is just like square root of u. Whenever you see the composite function in integral, most likely it is method of substitution if the derivative of that composite function is present. In this case, if this is my u, what is the derivative of this? Derivative of x square is 2x. Derivative of x is 1. For 1 it is 0. So the derivative of this whole thing is 2x plus 1. Is 2x plus 1 present? I see 4x plus 2. Now if you just see and take 2 common from here, you get, if you take 2 common, you have 2x plus here you will be left with 1. So that derivative of this is actually present here if you simply take 2 common. I hope that makes sense. Okay. So in this case, we have to then say put x square plus x plus 1 is equal to t. Okay. X square plus x, because that's u. Put that u part or the composite part is equal to t. And then you differentiate with respect to x. Differentiate with respect to x. Okay. Then you get derivative of x square with respect to x is 2x plus derivative of x with respect to x is 1. Derivative of 1 with respect to x is 0. Derivative of t with respect to x is dt by dx. Okay. So therefore, I have 2x plus 1 is equal to dt by dx. Okay. I actually have 2 times 2x plus 1. So therefore, I can say, or actually just multiply both the sides with 2. If you multiply both the sides with 2, you simply get this 4x plus 2. Or you can take 2 common, one and the same thing. Let's actually multiply both the sides with 2. If you multiply by 2, you have 4x plus 2. Okay. And multiply this dx on this side is equal to multiply this by 2. So 2 times dt. Okay. So basically we multiply both the sides of the equation by 2 and take the dx on the left side. Okay. So that's what we have, 4x plus 2 dx. This 4x plus 2 dx is 2 dt. Okay. This was the important part of multiplying both the sides by 2 in order to get this 4x plus 2. Okay. Because we initially noticed that if you take 2 common, the derivative is present. Okay. I hope that makes sense. Now, since we have this and since we have this substitution, we can convert the entire equation in terms of t. So our integral becomes integration of 4x plus 2 times dx. This is 2 dt. So 2 dt. And this is square root of t. Square root of t. Very simple to integrate now. This 2 can be taken out of integral. So you get 2 integration of root t dt. Okay. Now, similarly, like we did, root t is nothing but t to the power half. Okay. So 2 times integral t to the power half dt, which is equal to 2 times t to the power half plus 1 divided by half plus 1 plus add constant of integration c. Okay. Now 2 times, make the replacement. Our t was x square plus x plus 1. Okay. To the power 3 by 2 divided by 3 by 2 plus c. Okay, because half plus 1 is 3 by 2. And I just make that replacement and convert it to x again. Our final answer should be in terms of the original variable. Okay, original variable is x. So our final answer should always be in terms of the original variable, which is x. So I convert that to x again. Now that 2 is in denominator's denominator, it can go in numerator. So that 2 will go here and become 4. 4 by 3 because of this 3. X square plus x plus 1 to the power 3 by 2 plus the constant of integration c, and that's your final result. I hope that makes sense. All right, let's see question number 10, a very important one for your exams. Integral of 1 upon x minus square root of x. Now, if you notice carefully, the square root of x, there is x and there is square root of x, okay? Uh, what is derivative of square root of x? Just to get an idea, what is derivative of this square root of x? We know if it is square root of x, the derivative is 1 upon 2 square root of x. So if you have square root of x and if you want to put it as t, you should have square root of x in the denominator, okay? Because it is 1 upon square root of x, 1 upon 2 square root of x. So if you want to put this as t, square root of x should be in the denominator, okay, for that substitution to happen, because the derivative should be present if you want to do method of substitution, okay. So in this case, you can just simplify this. You can just simplify this by writing, we know the x term is nothing but square root of x into square root of x. That x is nothing but square root of x into square root of x, because we need the derivative of square root of x, which is 1 upon 2 square root of x. Okay, we need that in the denominator. So what we do is we write x as square root of x into square root of x. Let's see what happens. So we have integration of 1 upon x can be written as square root of x times square root of x minus square root of x dx. That will become, now take square root of x common. So you have 1 upon square root of x and square root of x minus 1. Because you take square root of x common from here, you have square root of x left in the first term, 1 in the second term, and dx. Okay, I hope that makes sense. Now, if you put square root of x as t, or even if you can put square root of x minus 1 as t, doesn't matter either way, okay? If you put square root of x as t or put square root of x minus 1 as t, doesn't matter, because the derivative of 1 is anyway 0, okay? So you can either put square root of x as t or put the whole thing square root of x minus 1 as t, okay? Let's say we put square root of x minus 1, because the derivative of square root of x is 1 upon 2 square root of x. That 2 is not present, but that square root of x is present. Okay, the 2 can be managed. So let's say put square root of x minus 1 is equal to t. I hope that logic makes sense. Why do we do this? Now differentiate both the sides with respect to x. Differentiate with respect to x. So we have derivative of square root of x with respect to x is 1 upon 2 square root of x minus derivative of 1 with respect to x is 0. Square root of, the derivative of t with respect to x is dt by dx. Therefore, note that here we need dx divided by square root of x. We need dx divided by square root of x. So here we have 1 upon 2 square root of x is equal to dt by dx. If we need dx divided by square root of x, we can take the dx in the numerator. So dx divided by square root of x. If you take dx in the numerator, this square root of x, and this 2 in the numerator. So we have 2 dt. That is the substitution that we have for dx divided by square root of x. Okay. I hope that makes sense. Now convert the entire equation or entire integral in terms of t. So we have integration of that dx upon square root of x is 2 dt, and this 1 upon this is t. So this is 1 upon t. Very easy to integrate now. So this 2 can be taken out because it's constant. So this is equal to 2 is constant out of integration. So integral 1 upon t dt. So to integration of 1 upon t is log mod t plus add a constant of integration c. Okay. Now what our t remember that our t was root x minus 1. So we need to resubstitute that. So we say convert it in terms of x again. 2 log mod square root of x minus 1 plus add a constant of the integral c, and that's our final answer. I hope that makes sense. All right, let's move on to the next question. Question number 11th. Question number 11th Uh, if you notice, this is the composite part. X plus 4 is the composite part. The derivative of x plus 4 is just 1. Okay, so that is always present. 1 is always present. Okay, so you don't have to worry. So it is very simple here. You just put x plus 4 equals t because that's the composite part, and the derivative of x plus 4 is simply 1. So that doesn't matter actually because 1 is always present. You don't need 1. You don't need to explicitly bring 1. 1 is always present. So differentiate both the sides with respect to x. Derivative of x with respect to x is 1. Derivative of 4 with respect to x is 0. Derivative of t with respect to x is dt by dx. So therefore, we have 1 is equal to dt by dx. Therefore, just dx multiplies on here. So we have dx is equal to dt. So dx and dt both are same. Okay. Now convert the entire equation or integral in terms of t. Notice one thing, that in the numerator you have x, and here we have put x plus 4 is equal to t. So if you put x plus 4 is equal to t, from here you can say x is equal to t minus 4. Okay, this is an important thing because x is t minus 4, which will be used here, okay, in the numerator. So here we can say convert the entire integral now in terms of t. So we have integration of that x is nothing but t minus 4 divided by square root of, we know this x plus 4 is t, so square root of t, and this dx is nothing but dt. So dx, we can just replace it with dt. Now it is very simple to integrate because this is just a simple split. We can just split here, split the denominator in both the terms. So if we split the denominator, we get integral of t divided by square root of t. Just give that square root of t to both the terms. Minus 4 divided by square root of t dt. Okay. Now notice that this t is t to the power 1, and the square root of t is t to the power half. This is t to the power half. Okay. So we can actually simplify this. This t divided by square root of t, we can apply the law of indices. So we get 1 minus half. Because the bases are same, the power gets subtracted in division. So we actually get integral of bracket t 1 minus half, because that powers get subtracted, minus 4 t to the power, the t to the power half in the denominator. If I take it in the numerator, that will become t to the power minus half and dt. Okay. And 1 minus half is again half. So we have integral of t to the power half minus 4 t to the power minus half and dt. Okay. Now very simple to integrate. Just give the integral to both the terms. So you have integral of t to the power half dt, integral to the first term, minus integral of 4 t to the power minus half integral to the second term dt. Okay. Now t to the power half, the integral is t to the power half plus 1 divided by half plus 1 minus 4 is constant, take it out of integration. For t to the power minus half, integral is again t to the power minus half plus 1 divided by minus half plus 1 plus add the constant of integration c. I hope that makes sense so far. Now half plus 1 is nothing but 3 by 2. So t to the power 3 by 2 divided by 3 by 2 minus 4 t to the power minus half plus 1 is just like 1 minus half. Okay, 1 minus half is half. Again 1 minus half is half plus c. Okay, we can simplify this a little bit. We know that t was, if you remember, we need to convert it again in terms of x. If you remember, t was nothing but x plus 4. So we can make that resubstitution. So x plus 4 to the power 3 by 2. And this 2 is in denominators. Denominator can go in numerator. And divide by 3. Okay. Because this 2 is in denominators. Denominator goes in numerator. Minus. Again, this 2 is denominators. Denominator goes in numerator and becomes 8 along with this 4. Okay. And this t is nothing but x plus 4 to the power half. Okay. Plus constant of integration c, and that's your final result. I hope that makes sense. All right, question number 12. Integration of x cube minus 1 to the power 1 by 3 and x to the power 5. Notice that this is a composite function, because this is, if it was x to the power 1 by 3, this would have been simple function. But instead of x, I have x cube minus 1 to the power 1 by 3. So that becomes a composite function. Okay, so this is my composite part, x cube minus 1. Okay, now let's see, is the derivative of x cube present, x cube minus 1 present in this integral? What is derivative of x cube? It is 3x square. Forget about 3. Is x square present? X square is not present, but x to the power 5 is present. If x to the power 5 is present, can I write this x to the power as x to the power 3 into x to the power 2? Why do I do that? Because I found out that the derivative of this is 3x square. X square. So I can get that x square from this x to the power 5. Okay. So that is my logic here for method of substitution. So we can get started by putting this x cube minus 1 as t. Put x cube minus 1 is equal to t. Okay. Therefore, actually, before actually putting x cube minus 1 is t, let's move this a little bit down. Before putting that, we can just write this x to the power 5. So this integral can be written as x to the power 3 minus 1 to the power 1 by 3. And that x to the power 5 can be just written as x to the power 3 and x to the power 2 dx. Okay. Now we can say put x to the power 3 minus 1 is t. Therefore, just differentiate with respect to x. So differentiate with respect to x. So therefore, x cube, derivative of x cube with respect to x is 3x square minus derivative of 1 with respect to x is 0 is equal to derivative of t with respect to x is dt by dx. Okay, I hope that makes sense. Now, 3x square, what I need here is x square dx. Okay, in order to convert this to t, I need x square dx. And from here, in order to get x square dx, I can just take this 3 in the denominator. So I get, so first of all, this 3x square minus 0 is 3x square is dt by dx. Therefore, just take that 3 in the denominator and dx in the numerator. So I get x square dx. Okay, dx in here, 3 in here. So I have dt divided by 3. And that is my substitution. Now convert the entire integral in terms of t. If you convert the entire integral in terms of t, what you have here is equal to integral of x cube minus 1 is t. So this can be just written as t to the power 1 by 3. X cube is what? What is x cube? From here, this x cube is nothing but t plus 1. Okay, notice that x cube is nothing but t plus 1. So this x cube here can be written as t plus 1, and that x square dx can be written as dt by 3. We convert the entire integral in terms of t. Okay. Once you convert the entire integral in terms of t, this 3 is constant, can be taken out of integral. So 1 by 3 integral of, and this t to the power 1 by 3, we can just multiply it in the bracket. Okay. So this will become t to the power 1 by 3 times t plus t to the power 1 by 3 times t. plus t to the power 1 by 3 times 1 is t to the power 1 by 3 and dt. Okay, so that is equal to 1 by 3 integral of. Now this is we're using the laws of indices. I can add the powers. So this will become t to the power 1 by 3 plus 1. 1 by 3 plus 1 plus t to the power 1 by 3 dt. Okay, so that is 1 by 3 integral of 1 by 3 plus 1. So 1 plus 3 is 4 by 3. So 1 by 3 plus 1 is 4 by 3. Let me just write it clearly. 4 by 3 plus t to the power 1 by 3 dt. Now integration is very easy. It's just like x to the power n. So this is equal to 1 by 3. Integral of t to the power 4 by 3 is t to the power 4 by 3 plus 1 divided by 4 by 3 plus 1 plus t to the power 1 by 3. The integral is 1 by 3 plus 1 divided by 1 by 3 plus 1 plus constant of integral c. Okay, I hope that makes sense. Is equal to 1 by 3. Now 4 by 3 plus 1 is 7 by 3 because 4 plus 3, which is 7 by 3. 7 by 3 divided by 7 by 3 plus t to the power 1 by 3 plus 1 is 4 by 3 divided by 4 by 3 plus c. Okay, I hope that makes sense. Very simple, just simplification of algebraic terms. Now that 3 is in the denominator goes in numerator. Even here, 3 is in denominator goes in numerator. And that t, we can make substitution again in terms of x. Convert the entire equation now again in terms of x. So remember that t was x cube minus 1. So we get 1 by 3. This 3 will come in the numerator. So we have 3 x cube minus 1, which was t, to the power 7 by 3, divide by 7, because this 3 we took on the numerator, plus again this 3 in the numerator. So we have 3 x cube minus 1 to the power 4 by 3, divide by 4, plus add constant of integration c. Okay, we are almost done. Just this 3 and this 3, just take common and bring it out, and it will get cancelled with this 3. So this 3 and this 3, if you take it common out, it will get cancelled with this 3. So we can basically cancel those 3 out, and that's the final result of integral. I hope that makes sense. All right, question number 13. Very simple one again. If you notice, this is the composite part. Okay, composite part is nothing but, if you notice, instead of x to the power something or function of x. So for example, if you have x to the power 3, this would have been simple. But instead of x, they put here u to the power 3. So this is your u. Okay. Whenever you see composite function, try to see if the derivative of composite function is present. Now here, the derivative of 3x cube is 9. 3 times 3 is 9. X square. Forget about 9. We have x square. Okay. Because 9 is constant. It can be easily managed. We have x square. So we know that this whole thing can be substituted as t, because the derivative x square is there, and the constant can be easily managed, which is 9. Okay. So we can say here, put 2 plus 3x cube is equal to t. Therefore, differentiate both the sides with respect to x. If you differentiate with respect to x, derivative of 2 with respect to x is 0. Forget, don't write it. Derivative of 3x cube is 9x square is equal to dt by dx. If you notice here, we need x square times dx. We need x square dx. If you want x square dx from here, therefore we get x square dx. Take dx in the numerator and 9 in the denominator is equal to dt by 9. Okay, that is our substitution. Now simply convert this entire integral in terms of t. So we have integral of x square dx. Convert everything in terms of t. dt by 9. Okay. And this 1 upon this whole thing is t. So this is nothing but t cube. Okay. Notice that it's so simple now to integrate by doing that method of substitution. Integration of this 9 is constant, can be taken out of integral. So that will become 1 by 9. Okay. 1 by 9. T 1 upon t to the power 3 is t to the power minus 3. Okay. By laws of indices, 1 upon t to the power 3 is t to the power minus 3. And this integral is nothing but t to the power minus 3 plus 1 divided by minus 3 plus 1 plus add constant of integral c. Okay, I hope that makes sense. Now we can substitute the value of t. T was 2 plus 3x cube. 2 plus 3x cube. So I have 1 upon, okay, so this minus 3 plus 1 is minus 2. This 9 times minus 2 is minus 18. So minus 1 upon 18, okay, minus 1 upon 18. And again, t was 2 plus 3x cube. So 2 plus 3x cube minus 3 plus 1 is minus 2 plus add a constant of integral c. Now this to the power minus 2 is nothing but minus 1 upon 18, 1 upon 2 plus 3x cube square. That's minus 2 in the numerator. Power minus 2, if you take that in the denominator, it will just look a little bit neater and become plus 2 by laws of indices. And that is your result of integration that we need. Okay, I hope that makes sense.